Okay, the architecture talk, which feeling as weary as I do now, I wish I'd done yesterday. Um, but we'll give it a go. When I was writing this, I got very conscious halfway through, stroke bored, that you were hearing from me too much. So about halfway through, I decided Ross needed to finish this presentation. So I'm going to do the first half, and I'm going to hand over to Ross for sort of the deeper dive on the second section. But before I get into it, I wanted to deal with I don't know if elephant in the room is quite the right phrase, but we're quite, I think, transparent about what's going on the network, in particular maintenance, upgrades, that kind of thing. And we have lots of debates internally because there's a school of thought internally that we could do a lot more, we could say a lot more. But then there's my school of thought, which is, well, actually, if we say something on the status page for the next 2 weeks, that's going to be the cause of every random issue that's nothing to do with our network as far as certain customers are concerned. And sending you guys a text message at 9 o'clock at night, I expect invokes a bit of a reaction in you as to whether you're going to have a good night or not. So it's a continuing kind of tussle. But there are those who've said that we do too much in the way of maintenance, upgrades, and messing with things, because the old school way of telephony is you build it and you forget about it for 30 years. You needed to do that so the damn thing could pay for itself. And we're in this peculiar position that, yes, that's the world we're in, but really we're kind of a software as a service company now, and the way we're architected is very similar. And any modern company is pushing commits and pushing deployments continuously, all day, every day. And that's the way we work. But yeah, we do regular out of hours maintenance, and we notify about it if it's at risk. But like I say, we're continually pushing commits. In a typical day, there's probably 20 or 30 redeploys of something across the network. That could be the portal, that could be the API, that could be core routing. A lot of the stuff that you're gonna hear about, and most of the time you don't know about it. Most of the time you don't care about it. But that's very different to the way competitors work. And the reasons for those things are various, but pretty obvious. Bug fixes. Somebody opens a support ticket and they've discovered some esoteric bug that isn't affecting any other customer, but we can see why it's there. We'll patch it. We'll push an update for it, with obviously unit tests and suitable testing in the lab, behind me before it goes. Security patches. The way we work now with containerization means we can be right at the sort of the leading edge with packages and dependencies, so we're not exposed to things being out of date as we arguably were in the old world of physical machines or virtual machines, where you kind of install it and intend to keep it up to date, but sort of hope for the best. These are new features. We're continually adding new features, as you know. Config changes, and then probably the big one for the notified maintenance is when Alex is in a data center with a big hammer and there's things flying everywhere. The site is at risk in those circumstances, but there's only one site in an architecture that is built to be redundant, so we're only putting out an at-risk notice. There isn't a situation that I can ever recall where we've intentionally stopped the service for a few hours to do something. It's only ever incremental in part of the network. Now, the alternative, I'm not going to mention names, but we have a competitor that we like. Actually, they're really nice people, and we tend to say to people, if you don't deal with us, deal with them. And actually, they tend to say the same, and most of you deal with both of us. They had an outage, a complete outage in the middle of January. As a result, I forget how they phrased it in the RFO, but it was a DNS issue. And being nosy, we had a look at what was going on with their name servers. Now, incidentally, one of the things I covered off at the architecture talk last year was, although we don't fanny about running mail servers or DNS servers or any of that kind of thing, because why would we? It doesn't add any value to you. Actually, it detracts, because we're not going to do it as well as a specialist like, say, DNS Made Easy, or in the case of email, Google Apps and people like that. But these guys have a different approach. They have the old school ISP approach. We can, so let's build absolutely everything and let's control it. Well, it turns out they've got three primary DNS servers, and they're all running by 9.5, which is actually 11 years old. So they mentioned that they'd found an issue, and we're going to patch it. So being nosy, we looked a little while later, and indeed, as of the beginning of this week, one of them, probably the one that they'd had the problem with, was running by 9.9.3. And I can't actually find a release date from this, but it's at least 5 years old, because there's bug reports in 2013. So when people say to me, you do too much maintenance and you're always messing with things, why can't you be like? My response is something like that. And I think, you know, as customers, you need to choose which it is that you prefer, because I believe that you know, our approach is the right one. That's not to say it's perfect, but there's also something else that I hope many of you will relate to. You know, when you deploy a new piece of software and you're messing with it in the lab, and you're continually tweaking it, you're continually messing with the config, you're continually rebooting the box. For the first couple of weeks of that deployment, you're really confident, you know everything about that solution. And then you leave it for 6 months, and you're less confident, you're less familiar with it all. And then you leave it a year, and then you leave it 5 years. And as time goes on, you get more and more scared about touching that thing. I know very respectable ISPs that have moved data centers and had to build life support systems in cars to transport critical servers whilst keeping the power on, because they were absolutely mission critical to their entire revenue as their payment system, and they couldn't lose power because then they couldn't collect any revenue. So if you're messing with things and you're in this containerized world of continuous deployment that we're in now, we know what version everything is version controlled. Everywhere is using the same version. It's been thrown up and taken down and treated disposably many times, usually many times each day. So we're confident, we understand it. We mess something up, or we find a hole in testing, we fix the hole in testing, we go back to an old version, we're happy, we know it will come back. The alternative is that you live in this kind of state of fear, and frankly I've spent too many years in that state of fear. We've been there and had boxes that hadn't been rebooted for 10 years, that hadn't failed for 10 years, and we thought, God, what happens when that box fails? Well, we'll do X, Y and Z. But we never had the balls to actually just throw it away and start again, because it was mission critical in some way. Good news is we're not in that situation now. But I mentioned that things are far from perfect. We've adopted, well, we used to work in a kind of dev and ops sort of way. So you've got the Jean-Michel and Thomas that I mentioned yesterday on the development side, and then you've got, you know, Ross, Alex and others on the ops side. And there used to be isolation. You know, as the cartoon shows, dev could sort of log the bomb and it only affected ops. Dev didn't need to care about things breaking at 8 o'clock at night because they finished at 5, and that was an ops problem. Now with DevOps, we have this kind of shared state, and there's many benefits that come from that. Principally, the developers are really close to that code running in production, so feeding back issues with it, them observing issues with it is much more tightly integrated. There's no translation between ops or dev. You don't have this issue that, well, it works on my laptop, doesn't work in production. Well, containerization deals with a lot of that, but everything is much closer. But the downside is, if you do it wrong, you've got a bigger explosion that affects everything. And if your developers don't appreciate that they're involved in operations, then your operations by definition become a little bit weaker. And I'm not saying that's the case with us, but I'm saying there's learning there for dev and ops to work together. And I'm not ashamed to say we've still got lots to learn. We're always learning. You know, I think the day we stop learning, you know, we might as well close the door. But I believe the direction of travel is correct. and I'd commend the direction of travel to you guys, although it's completely atypical, in telecoms. So, last year I did an overview of the network, the SS7 piece, and I ended up saying the rest will follow at SimCon2. But then a year went by, and a year is a long time in Simwood time, so an awful lot's changed. So actually I need to go over what I did last year to bring you up to speed, which hopefully I'll do quicker, and then I'll hand over to Ross to take it on that little bit further. So I talked to Tom yesterday about what we're doing in the US, and sort of elsewhere in the world. The network is actually pretty large now, but I just want to concentrate on the UK. There's quite a lot to it. And to be honest, if we were starting up today, would we choose to go in all of these different data centers? Well, no, probably not. You probably just have two or three. But as time passes, people get bought. One has lots of power, one has lots of network. You kind of end up in this this distributed state. But we fundamentally operate in 3 availability zones. So the first is London, and we find Telehouse East and Telehouse North are supremely network dense. That's where most of our peering, particularly the bilateral peering, takes place. But the likes of Volta has loads of power. These guys don't have any power, so you tend to find all of our network is here, and all of our compute is here in London. We jointly own a 44-kilometre fibre ring around multiple data centres. So these others, we're actually present at either layer 1 or at layer 2. So that gives us superb diversity. And if you flick back to the OSI model I showed you yesterday, we're in control of it right at layer 1. Other than the physical fibre break, we're controlling the light going down those fibres. Slough is a little bit simpler because it's more recent. It's a single site that has lots of power. Doesn't actually have lots of connectivity because Equinix are suboptimal as far as their pricing for cross connects are concerned. So people don't tend to like to cross connect in Equinix. And then there's Manchester, which we also have a fibre ring, but only around three sites, and that really is a function of history, in that we were in this data center and Equinix or Telecity bought it and said, don't worry, nothing will change, your contract will remain the same. I thought, great, happy days. And then they turned around and they said, accept this service, this service, this service, this service, and this service, which we don't do anymore. So what they meant is we'll continue paying the same, but actually they'll remove most of the services. And pretty much everybody else apart from us left that data center. It was like a ghost ship at one time I went there. So we ended up needing to be in these other data centers. And we announced, I forget when it was, back end of last year, that we were closing Manchester because the cost benefit of having it with all of these distributed sites just didn't make sense when you looked at the level of networky type business that we did up there, and the utilization of it as a as a voice node. It's had a slight reprieve, which I'll come on to in just a second. So our basic strategy as far as the network is concerned has changed slightly over from where we were previously. We've got a pure optical core with Arista layer 3 switching. I've done lots of talks about why we use layer 3 switches instead of routers and how we bridge the gap in software. That's quite an unusual and modern way of doing it, but it's really worked well for us. When you start building a network, you start in one data center, you inevitably end up in 2. You've got choices of how you connect the 2. Now, some people just lie and run a VPN or something. Other people go straight in and lease some fiber, but usually people buy what's called layer 2 between the 2, which is across somebody else's network, a virtual circuit across somebody else's network. And that's kind of cool because you can draw it on a map. You can draw a line between those 2 sites and say that's my network. But actually that's not really your network. That's how your virtual circuit might look, or where both ends of your virtual circuit are on somebody else's network. And for some of the distant sites, like, you know, say Manchester and earlier on Slough, that had multiple point-to-point circuits coming in from third parties. We've now upgraded that to a pure optical core, and we're removing the point-to-point layer 2 stuff. And actually we're being a little bit more honest with ourselves that these point-to-point circuits, whilst they look great on a map, actually aren't really the way things are working. It's somebody else's network that's providing that. So we struck a deal with SSE, and we've said, right, okay, we want a VPLS on your national network, which you might as well think of it as a cloud, you know, effectively. So we just have a port in every site and 2 ports here, and it has a kind of any-to-any capability. It's actually the same underneath as it was before. We're just not really presenting it as having 2 ends. It's got multiple ends. For the international stuff, we needed to build this before we got where we are with SD-WAN. So we actually built a solution using, and this is something Alex did a lot of work on, DMVPN, which is a multi-point VPN that you might find underneath a lot of these SD-WAN solutions. But we added in BGP capability to that. So what that meant is we could basically have Simwood in a box on any third-party network, providing they could give us BGP. And it also meant that in a hostile environment, in other words, somebody else's network where we couldn't control everything between every host, whether they were next to each other or in separate racks, was encrypted. So every host is effectively a VPN node with BGP both into the core and actually into the you know, the relevant parties at that site. And as I mentioned, we're collapsing. Well, Manchester has a slight reprieve. We're effectively now collapsing it to a single site, given changes up there. But we are staying there. We're not closing it completely. Synergy.
Are you staying in Synergy?
Yeah.
Okay.
Yeah, because other people have come back now. And the other factor is that Equinix subsequently bought Telecity, and they've now put in place campus pricing on cross connects. So we don't need a dark fibre ring to get between those 3 sites because you can order a cross connect from Williams to Synergy.
So,
yeah, yeah. But no to your next question. Excuse me. So that's more how it looks. So we've got, you know, optical between Slough and London as the primary path. There's sufficient activity to have. You missed some off here, Ross. Anyway, an optical ring around, you know, around London. Yeah, around London. And then this kind of VPLS, any-to-any type connectivity with actually 2 diverse connections out of each side of this building. Because Bristol, that was the other factor with Manchester. Bristol is now on net. I'm not going to use the word data center, but there's a cupboard behind me, not the cupboard the AV guys are in, but there's what 4 racks in here. You know, this is on net with reasonable connectivity, and we've increasingly been using this as kind of a staging area for customer deployments. So ship it to us here, we'll set it up here, it can have your primary IP addresses on the network, you can test it all in an environment where Alex has just got to walk through the door rather than drive to London to hit things, and then when you're ready we can put it in a van and we can take it to one of the production data centers. But that also works as a DR type facility because space here is super cheap compared to, dare I say, a proper data center. I wouldn't want anybody running production stuff in here, but you could run production stuff if there was an issue with the primary. But so as a DR site, it works quite well. Just some stats on where we are, because we seem to, all of a sudden, you know, although voice doesn't represent a lot of traffic, we've suddenly ended up with quite a large network. So it's over 700. Everybody know what an ASN is? Yeah, 700 other ISPs effectively that we pair with. Many, by no means all, of those are bilateral, you know, cross connects, generally done at 10 gig, and over 90%, which is a crazy high ratio in the industry, of our traffic flows over those bilaterals rather than falling back onto transit providers, and that gives massive performance gains for you, because there's no third party in the middle. It's not hairpinning around somebody else's network between the 2 parties. It's just flowing directly over generally a massively over provisioned pipe. But nevertheless, we interconnect with multiple tier 1 providers at n times 10. An attack on the network has kept me awake for many years, and with the move to Arista and the layer 3 switching, we were able to build in quite a bit of software control to deal with issues in real time, because the problem is if you're serving cat pictures and porn, well, at least if you're serving cat pictures, porn is slightly more real time, people can cope with a 30-second outage. With voice, they can't. So in the event of a flood or another attack on the network, we have to deal with it quicker than your typical ISP, because otherwise you guys start phoning up. So we've got over 1 terabyte of DDoS scrubbing capability with a specialist partner that's all they do, and with the software controls in place, so that if there's an attack on a particular site, bang, we can swing things over, and they will cleanse things very quickly. Are you willing to say who the partner is who does your DDoS scrubbing? Yeah, Voxility. Oh, cool. Okay. Yeah. So, but actually, what we I can come on to it in the next slide. What we actually have with them, the way they work, is kind of everybody's a reseller. So we've got the overhead there for that, sitting there, whether we use it or not. So what we say to people now is, which is, I think on the next slide, is if we're selling you transit, we'll give you DDoS scrubbing just as part of it. You just tag a community and it's dealt with. But you've got a stage before the DDoS scrubbing, which is just black holing RTPH on our network and any peers that support it. Yeah, I mentioned the CWDM ring round Manchester and the DWM ring round London. So that presently runs at active DWDM, 40 times 10 gig. That's shared with, like I say, with other ISPs. We mutually own it. We're moving that to 40 times 10 gig, but also some passive waves, so we can light those at 40 or 100 gig according to what equipment people have. But there's certain, because we're going in and out of multiple data centers, there's retransmission required, so it depends on the topology as to how suitable that is versus strapping multiple 10 gig waves together. But so I guess the commercial point of all of that is what I've just said. These are the things that I talked about yesterday, things that we sell that you probably don't know about or don't think about us for. We'd love to help you with colo. Historically, we've never really done it, but because that's not our specialism. But we find now that, I mentioned, we seem to be the choice for new disruptive networks coming to the UK. So it's perfect, really, that they can come in, and indeed this invitation is open to all of you, and have a whiteboard session about how they're going to architect this greenfield deployment in the UK. They can stage it through our lab, do all of their testing, and then we can deploy it into production with optical waves, layer 2, or transit with DDoS scrubbing as appropriate, and of course SD-WAN as we talked about yesterday. So on the voice side, when we say voice, it's easy to think of IP, but for us we have 1 foot in IP and then 1 foot in the old world, 1 foot in the new world, 1 foot in the old world, if you like. So to cover off the SS7 piece, last year I showed you a slightly different version of this slide, which didn't have that, and it showed 50% of traffic flowing to each. We are unique in the marketplace in the way we interconnect with BT, because it's really complicated, and I actually confuse myself every time I try to explain it. But basically, BT will reroute around their network for a failure on their network. They will not guarantee to reroute around their network for a failure on our network. So the way most people deploy interconnects to BT is to benefit from geographical economies. So they probably, in many cases, have more points of interconnect than us, but they're less redundant. If you take an extreme scenario where somebody has a switch in Leeds and a switch in London, you could find that if there was an outage, power outage in Leeds, say, that all of their traffic from the north of England stopped because it was destined by BT to that switch in Leeds, and they need to phone BT up and say, actually, all of these prefixes, can you reroute them to London? Which is a bit of a ball ache, and operationally kind of unthinkable for us. So the way we do it instead is we connect to the same exchanges on the BT network, but from multiple sites of ours. So for those of you more familiar with networking, it's a bit like an MLAG. So we've got multiple sites that in each of their exchanges they just see as a fat pipe. So if we have a power cut in Slough, obviously we're quite excited about it, but from BT's point of view, all they see is a drop in capacity. So we suddenly swing from 30% of calls coming into each site to 50% of calls coming into each site. And we obviously have to manage the network to make sure there's headroom for that. But other than the calls that were in progress on this link when it went down, there's no interruption to service. We don't need to make these calls to BT to reroute things. But of course, BT Zero is something we talked about back end of last year, and frankly, I'm cross at myself that it took us so long to get that fed up with the shysters that it became a commercial imperative. But we're adopting the same approach to voice now that we do to IP, in that whilst BT may be the default transit provider, we've also got the opportunity to have bilaterals with everybody else, and we're actively pursuing that. So my target is 30% of inbound traffic to never touch BT, to be coming into the network directly from those other peer networks. And that of course improves diversity, but it also improves economics, because we're not paying them neither party are paying them a fortune in the middle for the luxury of being the former taxpayer funded monopoly. And so it's only a good thing, and we've got a very good guy on board that's pursuing that. So we're going through all of the porting agreements, the existing supply interconnects, trying to make them two-way, at the very least make them two-way in respect of each other's hosted ranges. In some cases going slightly further to include ported numbers, which is a significant proportion of it, but slightly more complicated operationally to do, because it needs a data file to be exchanged. But that's a very active push for us. And of course the good thing is that where it's not BT other than Virgin, these tend to be IP. So we've got some future proofing in there as well. And on the IP voice side of things, you saw this slide yesterday, save for that which I've just mentioned, and this. So I talked about the open porting initiative on the blog middle of last year, and it was a reaction to frankly some trolling by somebody around what we'd done with our porting policy. And actually all we'd done was articulate what everybody else does, but we'd articulated it, and that put us under fire for just saying what we do rather than keeping it a dirty little secret until we need to say what we do, which is the way other people approach it. So we tried to take that off the table and just make things better by saying, okay, let's set up this membership organization. Other wholesalers can join it, and we'll agree a memorandum of understanding, which one aspect of which is we'll make porting easier between ourselves, but also this really contentious thing with resellers, what we call wholesale ports, which aren't provided for under porting guidance, will allow between members of the Open Porting Initiative, because the economic reasons for us not liking them, namely the lifetime cost of that customer that's moved when they don't have to move, go away. And we invited all of our key competitors to join that, and they said many nice things, but so far haven't taken us up on that. So when you get an issue with a wholesale port, which I hope you won't, because you're all engaged and staying, but it does come up now and again, and you're grumpy, just invite them. They're more than welcome to join the Open Porting Initiative, and then you can do it. However, I will be, I don't know what the expression is, but I'll catch fire before Simwood joins BTIPX as a customer. Yet, actually, if I wasn't so puritanical about it, and I was a little bit more pragmatic, like some of our larger competitors, who are more sales oriented, it's fair to say, and don't really think about the bigger picture necessarily, we just joined, because then all of these scrotes that you can't presently port numbers from, actually I should say that scrote I've now managed to enter into official regulatory language in the UK. I've had people use it back to me talking about people. So yeah, all of these IPEX scrotes that hide behind the policies and the structure of IPEX, if we did join it, we'd be able to port. It would feel dirty, it'd be very dirty, it would be playing into what I've talked about as BT's remonopolization of the industry, but you don't really care about that. You just want the customer that you can't otherwise get. So the Open Porting Initiative is joining BT-IPX and will enable servicing as a service to members, of which Simwood is the founder member. So long story short, porting gets better in respect of IPEX scrotes in a manner that I can just about live with, which I otherwise couldn't.
So I was asked to give a bit of an overview on our application stack, how we work, why it's quite different to some others you'll know, and the move to containerization and some of the recent changes we've made there. We use Docker, and as lots of people say, containerization is quite hard. Done properly, it seems to be even harder. So we've changed it again. We've talked before about Simwood Container Network. This was derived from the original Docker networking not really giving us what we want, such that each container is running BGP, basically announces itself to the host and then the host to the public network. That's one that Simon probably understands better than me, but basically it let us solve a lot of the problems around Docker's own networking, and the containers themselves take responsibility for, announcing their presence on the network. So they announce an IP and take it.
The point is they're a first class.
Yeah, they're not.
Would be.
Yeah, they're not like natted or forwarded behind anything. It's also great for our Anycast services, because a container can start up, announce its Anycast address from any host on our network, and suddenly it's there. We did all this originally with Rancher, and we've now moved to Debian base, and there were announcements on the status page recently about containerization upgrades and container host changes, and that's largely what it's been for. Obviously far better package support in Debian. There's no more what our development team defined as Docker in Docker. I've not been that involved with it. However, we did have the odd instances of Docker basically running Docker containers, which got a bit silly. Further improvements to networking, and it's consistent with all our bare metal hardware. So everything else we've got that doesn't run in a container runs on Debian. Everyone understands Debian. We all know Debian. Rancher had some peculiarities. So that's why we've had the planned maintenance in every site recently for containerization, is to move them all from Rancher to Docker. Bit of an overview about the sort of call flow, what actually happens when you make a call. We're just going to consider one direction here. So you make a call to out.simwood.com. We load balance at this stage primarily by DNS SRV. There are SRV records on that. If customer equipment respects SRV, then everything works. So they hit out.simwood.com, they'll hit one of multiple availability zones. Unless they're using particularly old versions of Asterisk, which do the SRV lookup once and then ignore it. So even if we change the SRV records, or don't change them, but for instance the first site becomes unavailable and SRV would tell it to try the second, it won't bother and it will send it to the first IP it got, which sort of breaks the functionality here. So we'll come back to that in a minute. After that you hit an edge proxy, that's Camelio in every case, I was going to say most cases, which in turn will route the call to an application server. At the moment, these are FreeSwitch. So this is just Dispatcher and Camelio routes to FreeSwitch. Where the containerization comes in, our FreeSwitch instances are containers. When they announce themselves to the network, they also announce themselves to the sort of thing that manages the edge proxies. So each edge proxy knows which FreeSwitches are available. If one is busy, then it takes itself out of the pool. All of that happens automatically, so we can spin up more as required or move them about. From there, FreeSwitch uses basically mod XML curl to talk to call routing. Call routing is entirely written in Node.js. Again, it's a container. It may be local to the same container host as the application server's on, it may not. And that's heavily integrated with Redis. So that talks directly to Redis. Everything involved in routing a call is entirely to Redis. We don't use MySQL, Postgres, anything like that at that stage. It's just too slow. It's also how we can manage something like 100 odd queries or 50 odd queries, I think, just to set up a phone call and still do all the real-time fraud detection and stuff is all.
Faster than anybody else, I might add.
Faster, yeah, with less PDD than anyone else. That's obviously the orange path sort of loosely reflects the signaling of the call, the purple being internal. So the actual call routing decides how to route it. Let's assume this is a call that's going to go out over a C7 interconnect onto the PSTN. Call will go to the IMGs and then out onto the PSTN. The RTP, in most cases, will flow directly from the IMG back to the caller, which is why it doesn't matter that we've got FreeSwitch running in containers. Although containers are still close to bare metal performance, they don't handle media. There's no media going through Docker and things. That just gets, again, somewhat silly. So, yeah, application server is currently FreeSwitch. It is a great switching engine. We really like it. It does everything we want it to in that sense. XML RPC, event socket layer, event socket library, thank you, are obviously used internally to talk between that and all our node-based routing engine. We have had some RTP media issues with FreeSwitch, various ones, which is why we're trying to bypass it where possible. But the great thing about the way this has all been architected is that absolutely everything's a microservice. So anything can talk to call routing. When you raise a ticket with ops, and so this is, I've had issues calling this number, they've got a little web page that they can type in the number and things. I can see exactly what would have been sent back to the FreeSwitch in a human-friendly decoded form, saying, well, this is what would happen with this call, this is what would look up, would check these fraud limits, would check this against this. They see all of that and can see where the call would have gone. But because other things can talk to call routing, so can, for instance, Dractail, which obviously we heard about a lot yesterday. So we've sort of revised where we're going with the call routing stack to end up with something a bit more like this. So the SRV stays the same for now. Edge is still Camelio, but Dractail and call routing are sort of merged much closer together. There's no longer this FreeSwitch making an XML request to call routing, getting a response. Also, at the moment, it's a one-off response. So call routing returns, this is what to do with this call in FreeSwitch XML. We've got some control with it afterwards. With ESL, we can monitor the state of that call, end it, do various other things. But the way Dractail works, we've got a much more real-time control of every single call. So rather than it just spouting back, this is what to do, every decision is a two-way thing. So, we don't just generate a dial plan. Everything else stays more or less the same. The carrier edge is just another Camelio, which will sit in place of, or in front of even the IMGs. But it's just a demarcation point as we move more and more to this bilateral communication with other IP-based providers. We obviously don't unnecessarily need to run them through boxes with very expensive codecs, or very expensive boxes with hardware codecs.
Really expensive, Richard.
In comparison.
I'm still hurting from the amount of discount I gave you.
They are very good boxes.
To be fair, they're also the boxes I understand that BT use at the other side, so that tends to...
It makes life a bit easier, yeah. And introduced RTP Engine into the mix. RTP Engine, for anyone that hasn't used it or hasn't heard of it, literally just handles RTP, doesn't do SIP signaling at all. But you control it from Camelio or Dractail, or I think there's a FreeSwitch module for it now as well. And it will handle RTP, it will transcode, but when it's doing other simple things with RTP, it's handled at the kernel level. So it's, I don't know what I did there. There we go. So it's far more efficient and can be controlled by Dractail. So again, the RTP will flow directly from there to the customer, there to the carrier edge, and then onto the carrier. And it's completely separated from the signaling. Obviously, we are distributed across many sites. We use Anycast quite heavily, so we use local Anycast. You've probably seen this slide before. As I say, every container, or some of them, announce Anycast IP addresses. Take Camelio talking to Redis, which is a bit of an odd example, but Camelio, Redis, call routing, etc., are all Anycasted. In most cases, if there's a Redis instance on the local host, it will use that one, but if one fails, we need to do nothing. It just automatically picks the next one, and everything continues seamlessly. We do that with Redis, we do that with call routing, we do that with various other core services that things talk to. So ultimately, any container falling over or anything that needs to be taken down for maintenance internally, like we need to upgrade call routing to a new version, we can do that seamlessly, and you'll never see it in a call. Doing a lot with Anycast. One of the reasons we introduced recently any.simwood.com. This has been in beta since 2018. Some customers are using it regularly. Whilst it was still in alpha, we had 2 customers in particular that were using it for production traffic. We just thought they were very good at testing. Then when it did go down for a brief time, because obviously it's an alpha, we said it would. We got a ticket saying this wasn't working, and then we found out they'd been using it in production seamlessly with quite a lot of their customers for a while. Not what I'd do with something labeled alpha, but never mind. This solves all the issues with stale DNS. Just the same way as, like, you know, Google DNS of 8.8.8.8 or whoever has 1.1.1.1. If you've got a single IP address, the DNS doesn't matter. We don't need to rely on SRV, we don't need to rely on asterisk looking it up again. We don't need to rely on changing it if we need to take a site out of root. It just works. It'll always use the best site for the customer. We do this in the US as well, so use any.simwood.com in the US. If you're over in the East Coast, you'll get New York. It just works again. We're hoping to have this in proper production for 2019, and to retire the current host names out.simwood.com, etc. entirely. They're not necessary. There's been a lot of work, most of which I don't understand, to be honest, from our development team, Thomas, Jean-Michel, etc., on making this work, and been very impressed with it so far. We're using it. We do have customers using it. Anyone who hasn't, I'd encourage you to at least try it. Let us know if it works with your setup. If it doesn't, tell us what doesn't work and tell us what you're using, and we'll do our best to make sure we get any of the bugs ironed out. But it's definitely the way to go from a call routing point of view.
That works for, sorry to interrupt, Ross, that works for what you'd previously send to out.simwood.com, but also what you'd previously mapped to reg.simwood.com.
Yeah, also handles
so
SIP registration,
that.
even though it's Anycasted. And it's done in such a way that obviously the customer, it wouldn't matter if anything changes behind the scenes, the registration will survive, the calls will survive as well. Yes, that's a sort of brief summary of where we are, and if anyone has any questions for either myself or Simon about the network infrastructure, do you want to come back up to answer them, or are you just going to stay there?
Well, I'll stay there till there is one, and then I'll very slowly get up.
I've been wasting energy, isn't it?
And where's the
mic.
throwable box? I might even get a lot. I can't lob it at Simon. He's got a mic.
Could you expand on some of the RTP issues you've been hitting with FreeSwitch?
Possibly. I wouldn't want to be pinned on specifics. So we had a couple where we had RTP, which was basically delaying, particularly on very long calls, like 1 hour, 2 hours plus. There was an incremental delay appearing on the call. That was an odd one to isolate, because apart from anything else, asking the support team to stay on the phone for 2 hours is not a good use of anyone's time. But it was one of the ones we had. We had a few with DTMF that just disappeared when we took FreeSwitch out of the media path. Some of it, I think, may be a bit sort of anecdotal, but it's just, we found issues with RTP, and if we then changed that customer's routing so that it never touched a FreeSwitch, those issues went away. So there are other possibilities, but this was, we still had FreeSwitch on bare metal before the containerization, so it's one of these, if you remove that as a cause and the problem goes away, that's the most likely thing. Where we've been able to fix the issue, as it were, for customers, we've been less bothered about it being, like, determining the exact underlying cause. FreeSwitch obviously isn't our product. We're happy to provide information to them, and we did have FreeSwitch Advantage at the time, and work with them to try and fix things. But from a servicing a customer point of view, if we can click a button, reroute the traffic, and make it do something else and just fix it, that's obviously the more appropriate solution. An RTP engine's proven itself to be much more scalable. Just because it's a lighter application, it does a lot less, and it gives us a lot more control over it, because whereas FreeSwitch, you've sort of the call is on that free switch, it's tied to that free switch, so you can control it via that free switch, which is fair enough. But RTP engine and its disconnected nature with everything else, even if the thing that was controlling that call was to be restarted or fail or anything was to happen to that link, another one could take over, could still, the RTP stream would be unchanged and something else can then start managing it. It's also got a few things we've not used yet, but been testing in the lab, where if we've got multiple RTP engines, we can basically pivot calls even if the entire box fails. So pull the power out of a server that's running RTP engine, and we get about half a second to a second gap in 300 calls that are on that one server, and it just picks up somewhere else. So that's quite exciting as well. And maybe we could do it with FreeSwitch, but we've found a way of doing it with RTP engine.
There's a bigger answer to that. I mean, to your specific, there were other issues like long-standing bugs that some of our more particular customers identified. So there's one that's been there 5 years or more, where I think it was one packet every 5 seconds was dropped out of RTP for no explicable reason due to timestamp weirdness.
Yeah.
But the bigger answer I was going to give you is, I touched on it in the awards last night, that there's pressures in making ends meet with an open source project, and FreeSwitch has changed dramatically in the last 12 months. They have gone far more commercial, externally funded, and a cynic might say fallen out of love with open source. And we love all the guys involved in that, and historically we've always paid for support for FreeSwitch, but under the new model, their support at 8 times what we previously paid just doesn't make sense. So we took the decision to demote FreeSwitch to be an application server, which it's very good at, and all of this coincided with RTP engine, which has been about for years, as a very a ludicrously efficient media proxy. We're talking 50,000 calls on a box type efficiency, where they're handled in the kernel. That got transcoding support in about February 2018. So you add those two things together, and then add in the love with Dractio, and RTP engine is something that the Dractio can control, and it's a logical path. To be perfectly honest, if I was building something today, Dractio would be my approach, but so would Asterisk would get serious consideration. I came back from Astricon 2016, and my takeaway was, we need to look at Asterisk, because there's this old thing that dates back to the original fork of FreeSwitch, which is that Asterisk doesn't scale and FreeSwitch does. Actually, that's complete bollocks today. Asterisk has been completely re-architected and is heading in a direction that we can see and is relevant. FreeSwitch was entirely relevant, but is now heading into wants to do video, and it's less about switching voice. It's becoming less relevant for us. So you put all that together, and that explains the reason.
That's one of the reasons for the move of it.
Great, thank you.
Anyone else? That was simple.
Thank you very much.
Excellent, thank you. Both.